This is Elasticity and Beyond. The video I asked you all to watch was probably not detailed enough and maybe even too fast for you to really absorb what you need to about this important concept. Important because if you are interested in economics not just from a social science point of view, but on how economics can relate to business and management, well, elasticity kind of tells you whether you need to raise or lower your price or whether you've found just the right price. So it's actually a pretty important concept to understand. And it's even more exciting if you know how to use it and calculate it. So in the videos you were shown this concept, right, of this graph, for instance, this being a sort of inelastic, sort of elastic demand line, because it's kind of in between perfectly elastic and perfectly inelastic, right? Well, as you notice, this demand line hits the quantity axis at 10 units, right? Well, guess what? This is an inelastic demand line, right? According to the video lesson. Well, guess what? This is the same demand line. It hits and crosses, well, it hits the quantity axis at 10. It's the same line. So guess what? You can't actually tell elasticity with your eyeballs. You have to calculate it mathematically. So yes, a demand line can be more or less overall inelastic or elastic, but knowing actually what elasticity is right at a certain point or at equilibrium, you can't use your eyeballs. You have to calculate it. The second thing I want to talk about was left out entirely. And that's this interesting notion that any given demand line actually has an elastic and an inelastic portion. For instance, if you take a look at this line, sloping downwards, you'll find that you'll reach maximum revenue right about here in the middle, right? And up here will be elastic, telling you that you should actually drop your price because quantity is super sensitive to a price drop up here and you'll get more revenue. And then down here, it's actually inelastic. And if you've gotten to a situation where you've set your price or the market has set a price down here, and then if possible, then you should actually raise your price because you'll get more revenue. That each line actually has an elastic and an inelastic section to it. Observe. On this graph, you've got a sort of elastic, sort of inelastic demand line. And this box represents revenue, right? It's the price at this point and the quantity demanded at this price. So when you take price times quantity, you get revenue. The box is revenue. But look what happens from this point when I drop price down to the next notch, right? I give up 2 boxes of revenue, but I gain 7 boxes of revenue for a net gain of 5. That means my revenue went up even though I dropped my price because the number of people who bought grew at a faster rate than the rate at which I dropped my revenue per item. Understand that price is revenue per item, right? So again, if I drop it from here, I'm going to lose these 3, right? I lose 3 boxes of revenue and I gain 6. I still make more money at this point. I make more money if I drop my price. But look what happens down here. If I continuously drop my price, I lose all this revenue only to gain 2 boxes of revenue. Price demand down here is inelastic. Quantity is insensitive to price drops, probably because most of the people who want to buy have already bought at higher prices, right? There's not many people left. There's a variety of reasons, but when you drop your price here, you don't get a revenue gain. You get a revenue decrease because you don't get a correspondingly equal or greater increase in quantity when you drop your price. Up here, when you drop your price, you gain revenue. This portion of the line is elastic. This portion of the line down here is inelastic. And maximum revenue occurs where the elasticity of demand is 1, somewhere in the middle. So the third thing that you were never told in that lesson I had you watch is what changes elasticity. If we know it's important, we know how to calculate it. We know now that demand lines have parts that are elastic and parts that are inelastic, and we know that it helps tell us whether we should raise our price or lower our price if we're able to. What changes it? Well, essentially, there's a list. So you now have 4 lists. So there's one here for demand and there's one here for supply. So there was a list that shifted demand lines and a list that shifted supply lines, and now there's also a list that changes the slope or elasticity of the demand line and the slope of the supply line as well, right? So quickly, without boring you to death, let's talk about some of these. So under demand, customs means not, the guys at the border, it's customs and heritage and norms and social norms and things you do, like celebrating Christmas or Hanukkah or whatever, right? There are certain things, perhaps products you would eat or use at those time periods. They're not going to, their demand is much less sensitive to price changes because you just can't get away with not having them during those seasons or those celebrations, right? Substitutes. If there's a place to go to buy your product when the price goes up, you will leave and go and buy it elsewhere. So the more substitutes there are, the more elastic and responsive quantity demanded will be to a price change. Luxury versus necessity. The more something is a luxury, the more elastic it is, right? So if you don't really need it, then when the price goes up, the quantity demanded will drop rapidly. Durables versus consumables. Durables are usually longer term purchases. They're usually things for, like, washing machines, automobiles you've saved for a while. A small price increase is not going to deter you from buying. So the more consumable, like a can of pop or underwear, like that stuff, if it changes drastically, the more elastic those products are, the more consumable they are. Time to convert and duration of the price change basically means if a price change goes up, and it takes a long time for you to switch, for instance, from a gas automobile to an electric one or something that takes time, then the more inelastic. So in other words, if you can switch quickly, so if the price change happens and you can switch quickly, the more elastic demand will be. If you can't, then it's going to be inelastic demand, right? Unless the price changes for a long period of time. The breadth of the category means the broader the product or service, the more difficult it is to switch, so the more inelastic, right? You can switch from Coke to Pepsi pretty quick, but it's much more difficult to switch from soda to something else because there are less perfect substitutes the broader and broader the product category. So again, the broader the product category, the more inelastic demand is overall. Likewise, with supply, the longer it takes you to bring a product to market, the more the more inelastic it is, right? So if price suddenly shoots up, you want to get this stuff to market, you want to sell as much as you can and make as much profit as you can because the price has gone up on the market. Well, if it takes forever, suppliers are still not going to be able to dump a lot on the market. So the longer it takes, the more inelastic supply is. Likewise, storage. If you can plop something in storage like wheat for years at a time, then it's very quickly to plop it out of storage, right? If you can't store it, then you can't dump all this supply on the market very quickly. So the easier it is to store, the more elastic supply is. And likewise, cost. The more something costs, the harder it is to make more quickly, right? So the more elastic, the cheaper it is. So the fourth thing that wasn't really elaborated on in that lesson that I told you to watch was how to actually do a calculation. So the formula, quite simply, is elasticity of demand is the degree to which quantity changes in the numerator over the degree to which price changes in the denominator. So what you're actually doing, remember, price is the revenue per unit, right? That's how much revenue you're making per unit. So what it's measuring is how much is revenue going to change because you change price. So for instance, up top, let's start at the bottom. If you raise price, say you drop price by 10%, you're going to lose money unless you can get the number of people who buy to go up by 10%, right? Because if you make 10% less per unit, but you sell 10% more units, it's a wash. You end up with the same revenue. So when you actually get an answer to this formula, say -4, and it will always be negative, right? Because it's an inverse relationship between price and quantity change, right? When price goes up, quantity goes down. So that's opposite. So it'll always be negative. So let's say you get a number that's -4. What it tells you is that when you change price, the quantity will change by 4 times as much. It's a ratio. -4 means 4 to 1 in the opposite direction. So if you drop price, quantity will go up 4 times as much, which of course means you will end up with more revenue. So elastic numbers are greater in absolute terms than 1. So they're -2, -3, -4, right? Inelastic means less than 1, or greater than 1 mathematically, but less than 1 in absolute terms, right? So it'd be -0.5 or -0.2. Let's try an example. So in this example, what we're going to do is we're going to look at, say, some random product with a demand line we're not going to specify, but I'm going to tell you that it's got at equilibrium, or at least at the market equilibrium we're currently at, or whatever point we're selecting on the demand line, the quantity demanded is 100 at a price of $10. So the revenue at that point, of course, is $10 times 100 units. That's $1,000. Well, let's say the price then goes up to $11, and here's the first thing you have to remember. If you've taken calculus, what we're really getting at here, or even functions, it's instantaneous rates of change. Don't pick two prices that are 100 miles apart. You want to take your current price on the demand line and pick somewhere really close to it. Don't go too far. You're looking for just elasticity, that is the rate of change of revenue, right at that point. So if you raise price to $11, what happens? Well, let's say the quantity demanded goes down, which it must, because that's the law of supply and demand, right? Inverse relationship. Quantity demanded goes down to 95. Well, what does that equal? That equals $1,045. So our revenue's gone up. So already, if you're getting this, you understand that you should raise price, that demand elasticity at this point at $10 was inelastic. It wasn't as responsive as the price change, right? Quantity was not as responsive as the price change. So it made sense to raise price because you were going to get more revenue from it. But how you actually do the formula? Well, it's percent change. And I find a lot of people struggle with one of the most important formulas in life, percentage change. Right? What you want to do is take the change in the numerator and divide it by your starting point in the denominator. So it's your ending value, right, minus ending value minus starting value, which equals the change, and it will give you the right sign, positive or negative too, right, if you do it that way, divided by your starting point. That's percentage change. So what we want is the percentage change in quantity, which is quite simply 95 units minus the 100 units we started with, is going to give us, I'm going to divide it by 100, right? You get a negative 5% decrease in quantity, which we clearly can see in our little chart. Price, well, it went up 10%, you can tell, right? But mathematically, that's ending value minus starting value divided by starting value. Gives you a 10% increase, positive. Then in the formula, if you recall, you take the percentage change of quantity and you divide it by the percentage change in price. It's a ratio. How much more does quantity change than price? Not the amount, but the rate of change of price, right? What is the rate of change? How much bigger is the rate of change of quantity compared to the rate of change of price? And so our negative 5%, as a decimal, remember, negative 5% downward change in quantity is only half the size and opposite direction of the 10% increase in price. So it's inelastic and we're going to make more revenue. So raise your price. That's how it works.